uh, very connected from class 11th, and it's very important. And it is especially for inorganic chemistry. Like if I'm going to give you any compound, inorganic compound, that will be covalent compound, you can easily draw the structure. If you can draw the structure, you can easily calculate the hybridization structure, and you can easily count the number of different types of bond like sigma bond and pi bond. And it is very, very important for inorganic chemistry. So I'm going to write first the rules to draw the structure. Rules for drawing a structure. A structure of what? Covalent compound. Basically, like you know how to draw the structure of H2SO4, H3PO4, H3PO3, H3PO2, or H2S2O7, like this type of compound. So I'm going to write some rules, which is very important. So you are going to write it with me. And the first rule says that hydrogen, H for hydrogen and F for fluorine, can never be central atom. Can never be central atom. And I think everyone knows what is central atom and what is surrounding atom. If you are going to draw the structure of CH4 from class 10th, you know the structure of CH4 is like this, or you can draw it in your way. This is the structure of CH4, right? So you know the central atom is your this, and surrounding atom is these hydrogens are surrounding atom. So I think you are aware of this surrounding atom and central atom. So the first rule I wrote it here is that hydrogen and fluorine can never be central atom. The second rule is very important. If oxygen is present between two atoms, if oxygen is present between two atoms, then it always forms single bond. This is the general criteria. It always forms single bond. Whenever oxygen will be in between two atoms, it will form single bond, always. The third rule is here. If oxygen is present at corner, if oxygen is present at corner, then it forms double bond. Corner, that means if oxygen is surrounding atom. Here corner means your surrounding atom. If oxygen is your surrounding atom, then it will always form double bond. And if oxygen is present in between two atoms, then it forms single bond from left or right. Are you getting my point? If we are moving to the next rule, which is also very important, fourth rule, if negative charge present on oxygen, oxygen is very important, on oxygen, then it forms single bond. Single bond. Actually, we do generally draw the structure of oxy acid or oxo acid. Basically, what is oxo acid? So in oxo acid, oxygen is always present there. If you have studied the block of the element, like in class 11th, if you have studied S block or P block, and you will study in class 12th the P block like H2SO4, like H2SO4. You have heard of this H2SO4, or you can see HClO4, and you can see H3PO4. So what is oxy acid? Non-metal, any compound in which non-metal plus oxygen plus hydrogen is there. If any atom where non-metal oxygen hydrogen is present, in any compound, sorry, not atom, in any compound, then that compound is known as your oxy acid. And you can see here, sulfur is your non-metal, hydrogen is also present, oxygen is also present. So this is oxy acids of sulfur. This is oxy acids of sulfur. In the same way, this is your oxy acids of chlorine, and this is your oxy acid of phosphorus. So how we are going to draw the structure, this is all about it. It's the fourth rule. I'm going to apply again. I'm going to repeat it again. Negative charge present on oxygen, then oxygen will form single bond. And if oxygen is surrounding atom corner, if oxygen is present at corner, or if oxygen is your surrounding atom, then it will form double bond. And if oxygen is present in between two atoms, then it will form single bond. The next is very important. If negative charge present on the molecule, if negative charge present on the molecule, then it is considered on central atom, on central atom. Just wait a minute. On central atom. And in bracket, you are going to write if oxygen is absent. What I want to say is that if you have a molecule, like let's say if you have NH2 negative here, so you know the central atom is nitrogen and there is no oxygen. So this negative charge will be on central atom. But if you have a compound in which oxygen is present, if you have an anionic compound, both are anionic compound. You can see this is your anionic compound and this is also your anionic compound in which oxygen is present. So this negative charge will be on oxygen. Are you getting my point? Say it's very easy. If on any compound negative charge is present, you will look for oxygen. If oxygen is not there, that means that negative charge will be on central atom. And if oxygen is present, then that negative charge will be present on oxygen. And whenever negative charge present on oxygen, then oxygen will form single bond. Are you getting my point?
Yes, sir.
Are you? Okay, thank you. Thank you for it. Now, the next, which is very important, if positive charge present on molecule, then it is considered on central atom. So very simple, positive charge present, this is very simple. Whether oxygen is there or not, the positive charge will be always considered on central atom. Okay, next, the seventh rule. Okay, I didn't write that part of the negative charge present on a molecule in which oxygen is present, then it will be considered on oxygen. So I'm going to write it here, except oxygen. Oh, wait a minute. If oxygen is present and negative charge is also present in molecular compound, then the negative charge is considered on central atom, sorry, on oxygen. If any compound is there and negative charge is there, then you will look for oxygen. If oxygen is there, then that negative charge will be equally distributed to oxygen. And if negative charge is present, oxygen is not there, then negative charge will be considered on central atom. These are some rules which is very, very important. I'm going to repeat it again. I will explain it. Then I will give you some example, and then I will give you some question regarding this. And this, how to draw the structure of these organic compounds is very important. Covalent compound, very important. Let me know when you are done with this. Done, everyone? Okay, what about your basic? I'm gonna ask you some questions after. I'm just gonna
Sir, can you show
first
fourth
ask you.
point?
Yeah, why not? Let me know when you are done with this.
Yes, sir.
Okay, I'm gonna ask you some question. Then I will repeat the explanation of the rules for the drawing structures. Can you tell me?
Can you just
Okay, Savage, I will just scroll up, also explain it. Now I'm gonna ask you some question. Please do answer that. Then I will say that. Just hold on a minute. Okay. So, Savage, I'm going to ask you some questions from everyone, not from you especially, and then I will show you the rules for drawing a structure and also explain it. So, can anyone tell me maximum bond formed by carbon, or are you aware of covalency? Can anyone
yes,
explain what
sharing of electron?
sharing of electron? Actually, covalency, if you want to, sharing of electron, what does this means? How many electrons it is sharing? Actually, if you want to go for how many bonds it can make, how many bonds it can make, that is indirectly correct, Savage. Tarif, Faiza, Madia, Shahid. Everyone is aware of this covalency, yes or no? Without this covalency,
Yes, sir.
you will definitely
Yes, sir.
do mistakes. That's why I'm asking. Covalency is basically how many bonds it can make. Like if you are going for hydrogen, you know, hydrogen has only one element in its outermost shell. So it will be the configuration is like 1s1. And you can see it has only one shell and it has an unpaired electron. So any element with one electron can come with opposite spin and make a bond. That means hydrogen has a covalency of 1. Hydrogen has covalency of 1. But if you are going for nitrogen, what you need to do? 1s2, 2s2, 2p3. So you know that the first part sorry, the first cell is will not share with the it will not be in bonding. The second cell, the last cell basically participate in bonding. You can see it has 2 electron and it has 3 electron. Number of unpaired electron is your basically covalency, because you know that in covalent bond, what generally happens, they share electron. Okay, so you can see here, it is the covalency is 3. Also, are you aware of coordinate bond? Yes or no? Please do let me know. This bond is very, very important. Coordinate bond.
Unequal sharing.
Unequal sharing. Basically, what happens, you can see here the covalency in the first step is 3. And also the covalency of nitrogen is 4, because it can form a covalent bond with equal sharing, because it has 3 unpaired electron and 1 paired electron, which is lone pair. So what it will do, it will donate its 1 electron to the element which required and then share the bond. Like if I'm going for the NH3, you know that nitrogen has 5 electrons in its outermost shell, and hydrogen will come like this, and you can see 1 lone pair is there. Here the covalency is 3. But what happens, you can see NH3 is there, it has 1 lone pair, and if a Lewis acid, that means H plus a species which has deficiency of electron, so what it will do, it will basically donate 1 of its electron. When it will donate its 1 of electron, hydrogen gained electron, and it will have positive and negative charge. When someone gain electrons, what charge it will have? It will have negative charge. Already hydrogen has positive charge. By gaining electron from nitrogen, it will have negative charge. So positive and negative will be cancelled. Is that clear, everyone? Now, since nitrogen donated 1 of its electron to hydrogen, so it will have positive charge, and we are going to show it like this: nitrogen making covalent bond like this, and it made a coordinate bond by unequal sharing. It is electron rich species. First it donated 1 electron and then make a bond with this. So we do it by this. This arrow shows that nitrogen donated its electron and then make a bond with it. Are you getting my point? Yes or no? So nitrogen can have 3 valency as well as 4 valency. Are you getting my point? Arif, Faiza, Shahid,
sir.
Diya.
Yes, sir. Sir, here
So-
nitrogen, which is getting plus charge, so this is coordinate bond.
Yeah, this is your coordinate.
So covalence here is 3.
Covalency, see, covalency is 3 for this compound, and covalency for this compound, NH4 positive, ammonium ion, ammonium cation, is 4. Covalency is basically how many bonds it can make, whether it is covalent or coordinate.
Okay.
Okay, now see, I'm coming to the first. Please take a screenshot, Savage. So what I was telling you is rules for drawing a structure. Rules for drawing a structure. First of all, hydrogen and fluorine can never be central atom. It cannot become in center. It can never be central atom. The rules generally belong to the oxygen, most part. You can see the second rule says that if oxygen is present in between 2 atoms, if oxygen is present in between 2 atoms, oxygen will make single bond. The third rule is also related with oxygen. If oxygen is present at corner or if it is surrounding atom, then it will form double bond. If oxygen is present at corner, then it forms double bond. Fourth rule, if negative charge present on oxygen, if negative charge present on oxygen, then it forms single bond. Now, how you are going to recognize whether oxygen has negative charge or not? So it's very simple. If you have a compound on which negative charge is present and oxygen is also there, that means that negative charge is for oxygen. That negative charge is for oxygen. You can see this rule number 5. If negative charge present on molecule, then it is considered on central atom. if oxygen is absent. If oxygen is not there, then that negative charge will be for central atom. But if but if oxygen is present, then that negative charge is for oxygen. That negative charge is for oxygen. You can see. And if positive charge present on molecule, then it is considered on central atom. And if oxygen is present and negative charge is also present on molecule or compound, then negative charge is considered on oxygen. These are some rules from which we can easily draw the structure. I'm going to take some examples. Please do write it. I think everyone done with this, right? Yes or no? Savage, Faiza.
Yes.
Yes.
Okay. Thank you. Okay. Like if I'm gonna give you, it's so simple. If I'm gonna give you SO2, what will be the structure? First of all, which first you need to recognize, and you can easily recognize. What do you think? Which one is central atom? Sulfur? Yes or no? Sulfur is the central atom. You are going to put sulfur here, and 2 oxygen is there. So 2 oxygen. I'm gonna put it here. You can write it vertically. I wrote it horizontally. That doesn't matter. Actually, here that doesn't matter. Now you know that oxygen is surrounding atom. Now you can see oxygen is at corner or surrounding atom. So what was the rule? Oxygen make double bond when it is surrounding atom. Simple. Are you getting my point? Yes or no? Please do reply.
Sir, can just repeat?
I gave you this compound and told you to write the structure. Okay, so you are going to check which one is central atom. So as in SO2, sulfur is the central atom. So I wrote it here, sulfur, and 2 oxygen is there. That means oxygen you can write anywhere. Now you can see oxygen is basically the surrounding atom. Whenever oxygen is surrounding atom or corner atom, it makes double bond. Are you getting my point? Actually, with this structure, you can easily know what is the number of pi bond, sigma bond, lone pair, and all that. Faiza, have you got it? Savage, Madiha,
Yes, sir.
Tarif, Sahid.
Yes.
Okay, now see. My first question is, can anyone tell me what is the valence electron of sulfur? Valence electron of sulfur. This is very basic question. So since S is negative. No, why S is negative? Where is negative? Shahid? Why you considered S negative? Is there any negative? You can see sulfur is 1 and this oxygen is 2. So sulfur will be in between oxygen. That's why it is central atom. This, if I'm going to ask you CH4, which one is central atom? Carbon. Are you getting my point, Sahib? Okay, I asked the question. What is the valence electron of sulfur?
6.
6. That's good. You can easily calculate. If you know the atomic number, which you should know, its atomic number is 16, and you know the first shell 2, the second shell 8, the third shell also 8, but we have 6 electron. So this is what is valence electron? Valence electron is the number of electron present in last shell. In last shell. So you can say 6. Now you can easily see that this sulfur used its 4 electron. That means 2 more electron is also present there as a lone pair. So questions can be asked, what is the total number of lone pair present in SO2, or what is the total what is the what is the lone pair, number of lone pair present on sulfur? So you can see number of lone pair present on sulfur is 1. Are you getting my point? Yes or no?
Yes, sir.
Okay, please do write it. I'm gonna just twist the question and let me see how many of you can solve it. Shawed, Arif,
Yes, sir.
have you got it all?
Yes, sir.
Okay. Can I change the slide? Okay. If I'm going to ask you the first question for SO2, related to SO2, number of lone pair present on central atom, Ca for central atom, or sulfur directly, they can ask. Number of lone pair present on both oxygen, or they can ask you a single oxygen as well. Total number of lone pair in this.
What is COA?
0.
In first one, number of lone pair present on C. What is that?
Ca is central atom.
Okay.
You can draw the structure, then you can find it. Okay, see, it's so easy, man. Sulfur is the central atom, oxygen, oxygen. Now, what you need to do, it's very simple. Oxygen is surrounding, then it will make double bond. Simple. This is the structure of your SO2. Now, you need to go for the valence electron. So, sulfur has 6 electrons. You can see in one bond. Do you know about this, the electron dot structure? Yes or no? Why I am drawing for one bond, 1 electron of sulfur? You can see sulfur has this 4 electron, but it has 6 electron in its outermost shell. So it will have 1 lone pair. So the answer here will be 1. Now, lone pair present on both oxygen. You can see oxygen and sulfur below. What did you say? Savage.
Two lone pairs, sir.
Very good. On oxygen. Basically, oxygen has also 6 valence electron. So 2 electron is already involved in bonding and 2 lone pair is there on 1 oxygen. So we have 2 oxygen. So total lone pair here for both oxygen 4. And total number of lone pair, you can see 2 oxygen has 2 lone pair, 2, 4 lone pair, and 1 lone pair is with sulfur. So total number of lone pair is 5. Is that clear? Shawez, Faiza.
Yes, sir.
Okay. Now you are going to draw the structure of SO3. First, see which one is your central atom, and accordingly you can do the test. Any answer, Faiza, Savez, Madiha, Mohammed Harif, Shahid? So see how it is easy it is. You can see sulfur is the central atom. You have 3 oxygen as surrounding
0
atom.
lone pairs.
Very good. You need to draw the structure first. Very good. Now you can see whenever oxygen is surrounding atom, it will make a double bond. So the structure is this. Very simple, isn't it? Are you getting my point? Now see, if you have a compound like NH2 negative, so whenever negative charge is there, look for the oxygen. If oxygen is not there, that means this negative charge is on the central atom. Central atom is nitrogen. I'm gonna draw the nitrogen here, and then you can see hydrogen is also there. Hydrogen has only 1 electron, so hydrogen will make single bond, and it will have a negative charge. Are you getting my point? Now, if you have CO3 minus 2, you can see negative anionic compound is this. This is your anionic compound, and oxygen is there. Whenever oxygen is there and negative charge is there, that means this negative charge is present on oxygen. First, you need to see the central atom. Central atom is C. You have 3 oxygen and you have 2 negative charge. So you are going to divide it, give equally to 2 atom oxygen. Negative, negative. Now negative completed. You can see negative on oxygen, negative on this oxygen. And whenever oxygen has negative charge, it will form single bond, and this is your surrounding, which is neutral. So this will be the, just wait a minute. This will be the structure of CO3 minus 2. Are you getting my point? Whenever negative charge is there, that negative charge will be for oxygen. You are going to divide it equally. Like if you have to, you are going to give 1 negative minus 1 to each carbon. Sorry, oxygen. And you have 3 oxygen, and if you have 2 negative charge, you are going to give 2 negative charge to 2 oxygen and left the 1 oxygen as it is. Are you getting my point?
So here, if there is no oxygen and negative charge is there, and so it is on central atom.
Can you repeat it again? There is no negative charge.
There is no oxygen and there is negative charge, so it will be on central atom.
No, it will. There is no negative charge, then it will be central atom. This is what you are saying.
No, sir. Like there is negative charge, but there, like for NH2 minus, so like other compounds also there will be negative charge will be in between.
Okay, see, yes, I got it. If you have any compound like BF4 negative, if you have any compound which has negative charge and oxygen is not there, then this negative charge will be considered on central atom. But if negative charge is there and oxygen is also there, then this negative charge will be on oxygen. Are you getting my point?
Yes, sir.
Okay, so I'm going to give you some more question. SO3 minus 2 regarding this SO4 minus 2. Please do it. And also PO4 minus 3. Tarif, this -2 negative represent that this compound has two negative charge. Simple, like this. CO3 -2. That means it is an anionic compound. If I'm going to ask you what is this, this is your neutral compound. If I'm going to ask you this is your anionic compound, you can say this is your cationic compound. So this positive negative is present on the compound, in the compound. Are you getting my point?
Yes, sir.
So anyone draw the structure of SO3 -2, yes or no?
Yes, sir. I do.
Still drawing or done? Please do let me know. Madhiya, Shahid, Arif.
Done, sir.
Done, sir.
Okay. So first of all, you are going to recognize sulfur is the central atom. Then go for, you have 3 oxygen. So you are going to put it like this. Now you have 2 negative charge. So you are going to give 1 negative charge distributed. -1, -1. Now your negative charge is completed. Finished. Now you can see when oxygen has negative charge, it will form single bond. When oxygen has negative charge, it is single bond. But when oxygen is surrounding bond, surrounding element with no negative charge, double bond. So this will be the structure of SO3 -2. Are you getting my point? Is this correct, Savage, Faiza,
Yes, sir.
Madhiya? Okay.
Yes, sir.
For SO4 -2 done or not?
Yes, sir. Done.
Yes, sir.
SO4 -2. Sulfur is the central atom. You have 4 oxygen now. Now you have -2 negative charge. So you are going to divide the negative charge equally, and you can see when negative charge present on oxygen, it will form single bond, and this will be double bond. Is this the structure of SO4 -2?
Yes.
Yes, sir.
Very good. For PO4 -3, it's also very easy. Now you can see phosphorus is the central atom. You have 4 oxygen atom and you have 3 negative charge. So I'm going to divide this equally negative. And when oxygen has negative charge, it will form single bond, and this will be the double bond. Isn't it easy?
Yes, sir.
Can I change the slide?
Yes, sir.
Yes, sir.
Okay. Now we are going for oxy acid, which is very important for your main block. Okay. So oxy acid, a structure of oxy acid. How you are going to recognize the structure of oxy acid? What is oxy acid? First of all, oxy acid contains, this is very important point for inorganic chemistry, contains at least one AOH bond. A is your central atom, which will be non-metal, One OH bond, at least one OH bond will be there. Now see.
Can you repeat
Oxy
what
acid.
is NM?
I will just repeat it. What is oxy acid? Oxy acid is basically a compound in which non-metal is present along with oxygen and hydrogen. Now, the first criteria for oxy acid is that at least it contains a OH bond. That means in an oxy acid, OH bond will be there, which will be directly connected with non-metal, with this non-metal. Are you getting my point? Yes or no? Like, I'm going to take an example. Like, if you have H2SO4, now you can easily see that sulfur is the non-metal, oxygen is also there, hydrogen is also there. That means this is your oxy acid of sulfur. Which non-metal is there? Sulfur. Sulfur is the central atom. Now what you need to do? This is your sulfur. You have 4 oxygen. So you are going to draw it like this. Again, you have 2 hydrogen as well. So if you are going to directly do this, this will be your wrong answer. Why? Sulfur can have maximum 6 bonds, not more than this. So what you need to, and you also hydrogen is also not there. So you are going to do this first, and you have two hydrogen. So you are going to give hydrogen to each oxygen. Now you can see oxygen is in between sulfur and hydrogen. So it will make single bond. It will make single bond. And these oxygens are surrounding atoms and alone. So it will make double bond. So this is your structure of H2SO4. Are you getting my point or not?
Yes, sir.
If you have another oxy acid, like let's say this is your HNO3. Now you can see hydrogen, oxygen, nitrogen. It is an oxy acid of nitrogen. So this is your central atom. You have three oxygen. You have three oxygen. For an oxy acid, there must be at least one AOH bond. You can see there is two. There is two. That is good. But at least one OH bond is there, and you have only one hydrogen here, so at least there will be one OH bond. Okay, so this will make single bond. Now the most important point is here. If you are going to make double bond with each surrounding oxygen here, this will be your wrong, because nitrogen cannot be pentavalent. Can't be pentavalent. It is second period element. Second period element. Absence of d orbital. Absence of d orbital. So nitrogen can make maximum of 4 bond, not 5 bond, and here it is 5 bond, so it will be wrong. So how you are going to draw the structure? First of all, it will be like this, double bond O, and this will be like this, and it will be like this. This is the structure. If nitrogen will make 4 bond, that means one of the bond from 4 will be your coordinate bond. So this is the structure of HNO3. Try it. You will get it after.
This is coordinate bond, N and O.
Yeah. This arrow basically shows your coordinate. Yeah, let me know when you are done with this. Everyone done with this?
Sir, nitrogen has 5 electrons that in outermost shell.
Yeah. You should
So why?
all. Yeah.
So why it can't form 5 bonds? Like 5
Exactly. I showed that. This way. Yeah. You can see nitrogen has 3 unpaired electron. Yes or no? So it can easily
Yes.
form 3 covalent bond, and one more bond can be formed by what? Donating coordinate bond. 5th bond will be formed by formed from where? Are you getting my point? If phosphorus is
Okay,
there,
okay.
let me take an example of phosphorus. If phosphorus is there, 15 is the atomic number, and this is your configuration. 2p6, 3s2, 3p3. You know, this will not participate, this will also not, but this will participate in bond. And if you are aware of this, if you know that, if third shell is there, 3D is also there. Yes or no?
Yes.
Yes or no? Now you can see this is your ground state. This is your ground state in which the covalency is your 3, because 3 unpaired electron, it can form 3 bond like pH3 or PCl3. Okay. Now, if you are going to excite this to like this, because you cannot excite this lone pair in nitrogen because it doesn't have vacant d orbital. I will show it to you as well. So now you can see that this has 5 unpaired electron, 1, 2, 3, 4, 5, and hence phosphorus can be pentavalent, but nitrogen cannot be. Why? You can see nitrogen has 7, so 1s2, 2s2, 2p3. So this will be as it is. So if it will form only the covalent bond, the covalency will be 3. It cannot, you cannot excite this because there is no 2d. 2d is absent here. So it can make 4 bonds only because of the coordinate. Are you getting my point?
Yes, sir.
So this is very important. Please do write it and write the structure of H3, PO4, PO3, PO2.
Where phosphorus will be in the center, right?
Yeah, phosphorus will be in center. Hydrogen cannot be. And if more than one same type of element is there, it can also not be the central atom. Simple it is. Please make your basic strong. It will be very helpful to score for JEE mains. If you don't know the small topics like covalency, if you have doubt, please be clear with me. And this covalency will be cleared if you are aware of the atomic number, if you know how to do the electronic configuration, if you know why this 2D is not 2D does not exist here. So I'm going to give some more homework, and I'm expecting this from all of you to send me by tomorrow. Send it to the Learnivio's WhatsApp number. They will send it to me with name, please. These are some questions that I gave you. Everyone is written this.
Yes, sir.
Yes, sir.
I'm gonna write the first one. You can see I'm gonna write the first one. H3PO4. It is oxyacid of phosphorus. Phosphorus is the center atom. You have 4 oxygen. You have 3 hydrogen. When oxygen is in between 2 atoms, it will form single. So this is the structure. Is that clear? I'm gonna show this as well. You have 3 oxygen and 3 hydrogen. So you are not going to do this. You are not going to do this. This will be wrong. At least P double bond O, one P double bond O should be there. So you are going to do this. 3 oxygen is there. So double bond and H and H. 1 hydrogen is still left. So you are going to do this like this. This is quite important. The phosphorus oxygen.